she has designed and teaches graduate courses for McDaniel College that lead to a certificate in STEM instructional leadership. And at this time, I would like to give control of the webinar over to Dr. Bowers.
Thank you, Anita, for that introduction. Thank you all for joining us tonight. I know this is a busy time of year. Suddenly we looked up and it was November. Anita's going to give me control.
Yes, you have that now.
Thank you. That means that I have to then push a button. All right. And if you can let me know in the chat box if you can see my PowerPoint, that would be helpful. Great. Thank you, Kelly. Perfect. So we're here tonight to find out about a NASA-sponsored engineering design challenge that is opening. Will be opening officially the end of November. Registration open in December, and it's part of it actually is supported not only from the National Institute of Aerospace, but ITEA is also supportive of this challenge. I also want to always be thankful for the fact that ITEA and NIA are now partnering and supporting each other in the opportunity to use innovative educational technologies and also to share, kind of connect with others in this way. The 2019 NASA OpSpark Challenge has a new mission to it. Did anybody participate in OpSpark last year or in any of the past years? Could you just chat in the window and let me know if anybody had participated before? If you did, what we are now calling Mission 2 and Mission 3 were the parts that were in place. Mission 1 is new, and we're going to get a chance to explore a new website that supports Mission 1. There are 20 dedicated NASA technologies this year. So if you're interested in ways to bring unusual technologies into your classroom, this gives you a chance to really focus in on 20 very unusual NASA technologies and spin-offs from some of those technologies. We are partnering with Adobe Spark this year, which will provide some multimedia technology free to students as well. So we'll talk more about that throughout the presentation. And then just the idea that that multimedia technology and instructional technology is something that you can use with your classes even beyond the NASA OpSpark Challenge. As Anita has mentioned, I am at the National Institute of Aerospace, the Center for Integrative STEM Education. And these banners hang in our hallway. Looking at those banners, can anybody put in the chat box what might be important to NIA based upon the banners that are hanging in the hallway? We have at our foundation 8 universities. Does anybody recognize anything from any universities that you might know about? I can give you a clue for that part. Let me help you with that. These are our member universities, and if you look carefully, you can see some of the iconic buildings echoed within those banners that are hanging. The National Institute of Aerospace is kind of at the basis. There are the member universities, so we have graduate education as a central piece. We have research happening within those departments at those universities as well as at NIA. And then my work is with the educational outreach component. That's where NASA OpSpark sits. Where are you guys tonight? So I'm actually here in Hampton, Virginia, actually Yorktown, Virginia. And we heard some other people talking about the possibility of snow a little bit earlier. Just so we have an idea of who's represented out there, could you please put in the chat box where you are right now? Let us know where you are. So Kelly's from Idaho, but in Washington, D.C. Thank you. Andrew, where are you located? And Lori, where are you? Andrew's in Illinois. Jenny's in Reston. It helps to have some idea of where you all happen to be located. Nancy's in North Carolina. And there's a Miami, Oklahoma. Didn't know there was a Miami, Oklahoma. Tell us a little bit about the students that you teach. It will help me know which parts of this challenge might be of most interest to you. What ages are you working with? And what subject are you teaching? Either one would be helpful. So middle school industrial technology. Excellent. Andrew, I think you'll be interested in mission 1, 2, and 3. Lori, Kelly? So, another 612, technology and engineering. Excellent. The challenge actually covers kindergarten through 12th grade for mission 1, mission 2, and Lori's a STEM 7th grade. Excellent. So mission 1 would definitely fit into all of your curriculum. Mission 2 is grades 3 through 12. Mission 3 focuses on middle and high school. So it looks like everybody here could really benefit and could choose to be involved with mission 1, mission 2, mission 3. We're going to hone in a little bit about the idea of design challenges. Why do you use design challenges with your students? And can you give me a clue as to some of the challenges that you have used in the past? Has anyone used design challenges with your students before? I know with my students, when I'm in the classroom, the idea of having somebody beyond me, beyond the teacher, who's really looking at their work, and the idea of connecting with other groups, that real world component, that's really an important piece of what we're hoping to provide with this particular challenge. So let's hone in on mission 1. Kelly says, yes, you've used some NASA before, some Fab Lab before. Excellent. Thank you. Your feedback is helpful. Mission 1 focuses in on a new website that we're going to have an opportunity to do, and Jenny sent some solar power design as well. So we're going to find out a little bit, teach engineering asteroid impact lesson. Excellent. The Trace Space Back to You is a new website that I want to take you to in just a few moments. Mission 1 is a spin-off scavenger hunt squared. It is for students in K-12. It's intended to be kind of a very quick awareness challenge. And this really is, students are not designing within this piece. They're really going out and hunting and finding just different evidence of NASA spin-offs in their world. So I'm going to ask you, let me see if I can find my chat box that I can type into. Anita, can you guide me to the chat for everybody?
Sharon, I have noticed that whenever you are sharing your screen, you cannot see those usually.
Well, that's no good. So let's try this. I'm going to ask you guys, I'm going to take you first to the spin-off scavenger hunt squared piece. And then from there, I'm going to, from this, you should be able to see my screen. If you're in front of a computer, I think you'll have more fun if you get a chance to go in this yourself. So look for homeandcity.nasa.gov. The Scavenger Hunt Squared Mission 1 asks students to first do a scavenger hunt through this new website. This site actually existed before, but we've updated it with lots of new innovations. If you're in front of a computer, go to homeandcity.nasa.gov, and then I want to give you a minute or two to explore either the city or the home. If you click on, for example, Explore the Home, once it loads, then you'll have an opportunity to choose a room that you'd like to go into. So you can see how mine is loading. Choose a room, and once you click on that room, I'm going to zoom into the bathroom, then I can look around myself, and wherever these blue dots are found, these are spin-offs, NASA technology that makes life in my bathroom easier. With Mission 1, what we're asking students to do then is to go into this website, to search around the city, to search around their home, and to find an interesting spin-off. And as they first look and do the scavenger hunt within this website, they build their awareness of what might be around them in their own home and community. And then the second part of the scavenger hunt is that we challenge them to go find this in their home or in their community. Can you chat in the box, because I can at least see your messages come through. I can't send them to you, but can you let me know if you can get to this website? And then I really would like to just give you about 2 minutes to explore a bit.
Sharon, I have typed the URL into the chat box.
Thank you. Thank you. All right, Kelly's in. I'm setting your timer. You've got 2 minutes. Go explore. Have a scavenger hunt. Find some interesting NASA spin-offs that are in your home or your community.
Sharon, to try accessing the chat box, if you would draw your cursor down to the bottom, see if you do not get a pop-up menu that will provide the chat box icon.
Ah, you are so smart. Oh, excellent. Thank you, Anita. Wonderful. All right. You're down to a minute. I'm going to ask you to report back. Once you've been exploring inside the city or the home, type in what NASA technologies you found. Okay, your time is up. So Andrew, you were in the home and you found snow goggles with blue light cancellation. Very cool. Nancy found freeze-dried food and water bottle filtration. Jenny found some earthquake dampers. Kelly found some enriched baby food, water filtration, cordless vacuum. I think you guys can see that what fun students would have in actually traveling around inside of this particular space. With Mission 1, so the first scavenger hunt, you take them to this site and you give them some time. We set 20 to 25, 30 minutes to just kind of spin around to take a look and see what they can find. Then ultimately, they might come back and talk about memory foam or Invisalign braces or some of the kind of power the spin-off technology in their tennis shoes. But their piece is to take what they've learned from home and city and then do their own hunt in their home or community. What you see in front of you is an example of what some students were actually able to pull together. And so they found firefighting equipment and shock absorbers and solar panels. The items are then sent to us, and the names of the groups are put into basically a hat. I think there's going to be a little bit higher technology than that, but we'll draw from that name, from that group, one name or one team a month beginning in December. Those folks will then have the opportunity to have a Skype visit from a NASA innovator. So the idea is that the first piece, Mission 1, really is just about building awareness. NASA technology is designed for a particular purpose, most often looking back on Earth or going out into space, but we all get to benefit from that technology being used in a different way, being a spin-off from the original technology. That's Mission 1. Any questions about what might be expected of Mission 1? It really is intended to be quick, easy, and build that awareness. Let me see if I might have pushed something. Is there anyone else who can't hear?
I think it's coming in loud and clear.
Oh, okay. I'm sorry. All right. Well, thank you, Anita. One of our participants, Nainglwinoo, is that Nancy?
No, it is not. I'll communicate with them and try to find the problem.
Thank you. Thanks for checking on that. And I apologize that I've been chatting along and not everybody's been hearing. But audio good for Andrew. Everybody else seems to be good. Thank you. So, the Mission 2. Mission 2 requires a little bit more effort from the students, but really lets them then take the position of becoming engineers and coming up with their own ideas and innovations. They are to solve a problem redesigning NASA technology. For Mission 2, students are going to be given an opportunity to actually test their muscles and flex their muscles with the design process. The design process on the left is the one that we've given for those in grades 3 through 6. The design process on the right is the one that we have actually promoted for grades 7 through 12. And I think you'll find very parallel pieces to the design processes that you might be using as well. Students are also given design packets. And for this design packet, they work as a team, and their challenge is that they'll be given 20 different NASA technologies or spin-offs that they are then to repurpose and have them solve a problem that they've identified. In the mission packet, they are also kind of worked through some collaborative experiences. For example, there's a team building activity that starts out this work. And the students are asked to be able to come up with their own mission patch that represents their team. This particular mission patch is one that is shared with them, and it is the actual mission patch from the Space Transportation System 114. When you take a look at that, we might not necessarily realize that there's something representative about each piece of that mission patch. Does anybody know their International Space Station or their space or their shuttle history well enough to know what happened between STS 107 and 114? This patch was actually created to honor the memory of the crew, the Columbia crew that was lost in the shuttle accident. And if you take a look, you can see that the blue shuttle that is rising has 7 stars in that. That was to honor their crew their crew members before them. This particular mission patch also points out that the red sun represents the Japanese Space Agency that was involved with this as well. So the idea is that students take a look at a mission patch, this particular one, but then they get to work together to collaboratively come up with a mission patch that they will be sharing with as part of their project. To do this, we are providing them with a suite of resources from Adobe Spark. Adobe Spark Education is now providing a graphic tool. It's actually called Adobe Spark Post, a video editor called Adobe Spark Video, and then their final product will actually be a very small web page, an Adobe Spark page. By simply registering for this particular challenge, the students will receive all of those instructional tools. Adobe Spark is one of our instructional technology partners. So that's another plus to being involved in the project. And some of the NASA technologies. There's particles that are attached to the outside of boats to make them hydrophobic. They're going to learn more about heat retardant materials, and some of you saw some of that as you were doing your actual kind of scavenger hunt work as well. There's a chance to also learn about planes that can fly vertically. Just briefly, and this is not yet on the basic website, but I want to take you to be able to see what these resources are looking like. So I'm taking you into interesting. Here we go. Nope. I'm so sorry. I may not be able to take you to those. Ah, there they go. We're actually still working with a web designer on these pieces. So those of you with your technology backgrounds, it'd be an opportunity to be able to point students to particular technologies and to be able to understand them better. There's a potential industry area identified for those that we're going to be looking at as well. And for Mission 2 and Mission 3, students are required to select either a spin-off or an original NASA technology from the list that we are identifying for them. There's also an emphasis on the James Webb Space Telescope and some of the spin-offs that come from that as well. And many of these, the Smart Sail, the Walk and Roll Robot, it not only then allows an opportunity for the students to become comfortable with those technologies and learn about some of the amazing things going on around them, but then to have that opportunity again to turn that into something else and to spin that off to solve a personal problem that they've identified. So let's get back into that spot on the PowerPoint. So there's that focus on the technologies. It could also be the focus on some of the science that comes from those technologies. The James Webb Space Telescope, if you're not familiar with that, is going to be launched in 2021. Will give us some images that we can only just imagine. Some of the first bright objects. It'll help us know more about galaxies and changes in the galaxies, the birth of stars, some of the star nurseries as well. In many ways, as we were talking about the reason to do these, to me it's authentic STEM. It's showing science in action within the technology. It's the technology that is enabled by that science. It's really letting them see hand in hand how the need to do something spurs the technology creation. It's engineering to expand and change that technology and the use of that mathematics to help model and design. So that's Mission 2, and it's open now. It ends March 5th, and the students then at that point will be submitting, any time between now and then, they would be submitting their Adobe Spark page, which would be their website. Any questions about Mission 2? Let me move on to Mission 3 then. Mission 3 is just like Mission 2, except those who go into Mission 3 will have the opportunity to work with engineering mentors and business mentors, college students, and they will then also have the opportunity to take their ideas into a virtual world setting. The virtual world is kind of Second Life-like, and it's a place where the students are then challenged to take their spin-off innovation to create a model of that, a 3D virtual model, and also to develop a marketing plan and consider how they really might market their innovation. There are mentors, both engineering mentors. They'll have an opportunity to work with marketing students as well. And this year we're also bringing in some of the UTeach students who are STEM educator mentors. And these are some examples of what's been built in the past. The students are kind of taking their thoughts and creating a museum-like experience that you can actually walk through that museum and see kind of in 3D their thoughts come to life. Do any of you teach CAD or how to build virtual models or simulations? Tinkercad. So Kelly, Tinkercad was very popular last year. The students in the middle school category used Tinkercad to create some of their models. And in a few moments, I'm going to take you into the virtual world and let you see some of the work that they've done. AutoCAD would work perfectly too, Andrew. This would once again perhaps be an opportunity to have a way to implement what they've been using, a way to apply what you've been teaching them. We also have an opportunity to have the students interact with NASA engineers within that virtual world space. And so it gives them that opportunity to connect with people. And it also makes it kind of equalizes the distance. Last year, the winning students, one team was in Washington State, another was in Utah. Their mentors were in Virginia. So that gave them that opportunity to be mentored in a way that they would not have been able to be mentored. Their work is reviewed by Cornell University students and professors. So last year they were displaying their work in something called a glog. This year it's going to be in the Adobe Spark page. But you can see the feedback that came from the students. We worked with the Cornell rocketry team as well. And so it was kind of that near-peer design review that was very helpful too. So Mission 3 is open now. The web page will be due February 12th. That's the Adobe Spark page. 20 teams will be selected, and so the mentors will review those web pages and select 20 teams to move in-world. The teams will work with their mentors until March, to March 26th. The finalists will be selected by March 29th. And then the finalists, and we've had 6 teams as our finalists the last few years, they actually do a real-time presentation to NASA and to NIA engineers on April 10th and 11th. I'm going to take you in-world so you get a better idea of what I'm talking about when we talk about this virtual world. So I'm going to kind of minimize that piece and take you in-world. Can I have a thumbs up or just a note that, are you seeing the virtual world? Yes, yes, yay, this is working. I've come in kind of looking through the eyes of my avatar. So in essence, I'm actually, you can see kind of behind me in this space and in front of me in this space, but it's easier for me to navigate around and move in the virtual world. This is a protected environment. So when the students work in this space, you can only get in and have chat capabilities and building capabilities if you have usernames and passwords. I'm going to take you to the middle school winning team from last year. And it's kind of exciting, really, to see what students can create. These are the mentors from last year for the winning team. This team was 8th graders from Washington State. And one of their mentors is an engineering student from Hampton University. The other mentor is a graduate student from the Mason School of Business at William and Mary. And everything you see, the students created. This entire space is all student created. They chose to work with a cryocooler from the James Webb Space Telescope, and they've displayed information about the design of their U-fridge. They came up with a backpack cooling system. They had to talk about the science of that as well. Displayed their sketches. So you can kind of see that they've created this museum-like experience. Here's their James Webb model. They need to, as part of the requirement, create a virtual model of the original technology. And then let me get around the corner here a bit. This is their U-fridge, their backpack refrigerator that they created. And I think, Kelly, you were mentioning Tinkercad. All of their work was created in Tinkercad and then imported into this space. They also needed to come up with a marketing plan. So their thinking about the marketing plan is over here on the wall, about the product, the service, the offering, who the potential customers might be. They decided that the Global Red Cross would be a good place to start to market their backpack refrigerator. The winning high school created this world. There's their mission patch. We kind of run to the end so you can see that. And their description of their mission patch and how it symbolizes the different aspects of themselves and how they work together. And their cryo chiller. They too use the cryo cooler technology from the James Webb. And this is this team. These students are from Utah. You'll see later that the winning teams are brought to NASA Goddard, and they had never been out of Utah before they came to Goddard. Their particular world, and you can see they designed it much differently than the other group. And there's actually also the capability to pick up their models and move them around. They used AutoCAD as their design work. And they kind of created rooms off of the main central space, kind of like the spoke of a wheel. Let me go through this door. I hope I'm not making you seasick. So they set their problem statement: how can the NASA cryocooler technology be used to create a more efficient and environmentally friendly refrigerator? This particular group really used Godzilla as kind of their a bit of a namesake. You'll see Godzilla photoshopped into the corner of each of the corners of their room. Possible solutions sketched out. Their model of their James Webb. Again, they made the model something that could be picked up and moved and examined from all sides. It's pretty impressive what these kids can do in this particular space. So Mission 3 gives them the opportunity to be selected to move into this virtual world space. It allows the students a chance to be mentored by college students, to interact with NASA folks within this space, and then really to take their creative thinking to another level. Before we leave the virtual world, any questions you might have? So I'll take you back into the presentation. The winners do come to Goddard Space Flight Center In the far right-hand corner, you'll see those are the Utah students as they were presenting out to James Webb researchers. They also get the opportunity to meet Peter Cullen, who is the voice of Optimus Prime, and do some public service announcements with Peter Cullen. And they have some behind-the-scenes workshops. They have an opportunity to work with some of the researchers and just tour in some places around Goddard that they would not normally get to see. Questions about Mission 3? So if you have any interest in Missions 1, 2, or 3, they will be opening soon. The registration is going to actually be not until the first part of December, but the design packets, once you register, will be available to you. Here's my email address. I would be happy to help and explain anything in more detail. I'm also happy to Skype in and kick off the mission work. So if you're interested in starting this with your students and you want to do Mission 2 or Mission 3, I'm always happy to kind of Skype in and answer questions and encourage students to participate. Before we wrap up our presentation, any questions that you might have? So the website, let me make available to you the website for NASA OpSpark. And if you go there now, you'll be able to see the kind of the overview of missions 1, 2, and 3. The registration, as I said, will open in early December. Once you register, you'll receive the design packets. And at any time, I'm happy to answer any questions or be involved if you would like to have any help in kicking off the challenge with your students. Thank you all for joining us tonight. Anita, do you want to take over control?
Yes, I'll take it back. And I want to thank the attendees for your attention and especially your participation during this presentation. Give you one last chance if you have any other questions for Sharon. If you do, please unmute your microphone or ask or type it in the chat box at this time. I hope you did take Sharon's email down so that you can contact her later for any questions you may have or entry into that. And if you look in the chat box, Sharon did share that with you. I'd like to invite you to join us for our next webinar presentation on December the 11th at 4 p.m. when our presenter will be George Valenzuela. His presentation will be on how to develop computational thinkers. Computational thinking is a higher order problem solving and cross-curricular skill. As CT is understandable to both machines and humans, in this session, technology and engineering educators will learn to draw on familiar concepts that connect their previous learning to foundational computer science practices that involve designing solutions that leverage the power of computing. George will share authentic examples, both in engineering by design and other curricula, best practices, and resources for helping any educator get started with mastering computational thinking. We'd like to thank Dr. Bowers for sharing such an engaging presentation, but we would also like to thank you, the attendees of this webinar, for your participation. You will receive a follow-up email with the information for accessing this archived webinar. Good evening and goodbye. Thank you, everyone.